Alright, we got two more examples here. The first example, I want you to notice how both of these equations are set equal to y. When that happens, what we'll do is look at the expressions themselves. And since both of these expressions are equal to y, I can go ahead and set them equal to each other. This is our first kind of substitution. Negative 10x plus 29 is now equal to 5x minus 1 because both of these are equal to y. So I actually go ahead and start in on some algebra. I usually use my steps for don't call me after midnight. I can't distribute and I can't combine, so I start by moving my variables. I don't like that it's a negative 10x, so I added 10x to both sides. That means on the left-hand side you just have the positive 29, but on the right-hand side you have the variables that you have to combine. 5 and 10 make 15, so 15x minus 1. Then I go ahead and I have to add 1 to both sides because I'm solving a two-step equation. So 29 and 1 give me 30. And so I have that 30 is equal to 15x. If I'm going to get the x by itself, I have to undo that multiplication. And so if 15 is being multiplied by x, I need to undo, or I need to divide by 15. I have to do that on the left and the right hand side. On the left hand side, 30 divided by 15 is a positive 2. So I just found out that the value of x in this system of equations is a positive 2. What I'm focused on now is finding the value of y. So if I know that in both of these expressions the x value has to be a positive 2, I can pick either one and I can plug in to find the value of y. I personally prefer the least positive or the least negative numbers, and I like the smaller numbers. So I'm going to choose to use the expression y equals 5x minus 1, and that's what I'm going to substitute my x value into. You could use the other expression though, you'll get the same answer. Instead of 5x minus 1, I'm using substitution. So when x is 2, 5x is actually 5 times 2, and then I have to subtract 1. So 5 times 2 is 10 minus 1, and that tells me that the y value is a positive 9. So for this particular system of equations, the solution is when the ordered pair is positive 2, positive 9, or x has to be 2 and y has to be 9. That is the only way this system will have a solution. Alright, let's look at the next one. See how that one's a little bit different. So on this second system of equations, the first equation is in slope-intercept form and the second one is in standard form. So what that tells me is that I need to be focused on a different kind of substitution. Wherever I see y in the first equation, I'm going to focus on where I see y in the second equation. So if y is equal to 3x plus 2, anywhere in this second equation that I see a y, I can substitute in the expression 3x plus 2, and that's exactly what I'm doing here. And then I'm gonna just finish off the equation with set the equation equal to 11. I can't avoid the distributive property here. I have to do it. So I have 2 times 3x, which is 6x's, and then I have 2 times 2, which is positive 4. So at least I have all positive numbers here, and then I just finish out the equation equal to 11. After I do the distributive property, I have to combine like terms. I have a 1x and a 6x to make 7x's, and then I finish out this two-step equation that says 7x plus 4 is equal to 11. So I'm getting close to finding the value of x. I have to get the x by itself though, so we subtract 4 from the left and the right. And then 4 minus 4 is 0, so the 7x is by itself on the left, and 11 minus 4 is positive 7 on the right. Now I have to undo the multiplication, so I divide by 7 on both sides, and I end up with x is equal to 7 divided by 7, which is 1. So I get to look back at the original system of equations and ask myself, where do I want to plug this x in? You could use either equation, it doesn't really matter, but if you're looking at the first equation, you'll notice that it's a little bit more straightforward. I'm not going to have to rearrange anything, the y is already by itself. So I have chosen to use that particular equation to help me find the value of y. If the equation says that y is equal to 3x plus 2, I can use substitution one more time and say that 3 times x is actually 3 times 1, and then I continue to add the 2, and plugging this value in will allow me to find the numerical value of y. 3 times 1 is 3, and then I have to add 2, so when I do 3 plus 2, I get a positive 5, so y is equal to 5 here. Or the solution to this system of equations is when x is positive 1 and y is 5, as an ordered pair 1, 5. Here you've got two examples of two different systems of equations where we used substitution for both of them, but we did have to do that substitution in different ways. Let me know if you have any questions or if there's anything I can help you with.